Hey guys, welcome back to CEBOX tutorial channel, and this is our situation number 39 from CE Board Exam November 2019 for Structural Engineering and Construction. A steel column with unsupported length equal to 4.5 meter is to support an elevated floor. Okay, available section is L 100 by 100 by 16 millimeters. So ang meaning kasi ng L sa steel section is angle bar. Okay? Or, yes, angle bar. So, use Fy is equivalent to 248 megapascal. And, given naman yung mga properties ng ating section. Okay? So, kung napapansin nyo yung ating section, okay, hindi siya symmetrical sa X sub O and Y sub O, hindi ba? And since ito ay column under to sa chapter 4 ng steel design ng aming playlist. Okay, so this is under sa flexural torsional buckling. So kung gusto niyo matuto kung paano mag-solve ng isang column under sa flexural torsional buckling, meron po kaming naka-prepare na playlist under sa steel design, under po sa chapter 4, ayan, sa compression member, flexural torsional buckling. So pag inopen niyo po yan, meron po kaming introduction and meron po kaming problem 1 and 2. And latest po to, under po to sa NECP 2015. Ayan, nakalagay naman po sa atin. Pero ito po kasi yung problem na to ay noon pang November 2019 and ang ginagamit po kasi sa board exam ay mga old NECP version. Okay? So yun po yung gagamitin natin dito. So, number 1, find the allowable load for double angle welded together. So, since allowable load ang pinapahanap under to sa AST. Yan. Pero kasi sa NECP 2015, dalawa na yung halos ginagamit, LRFT and AST. Okay? So, kung double angle yan, so, sabihin, magkakaroon na naman tayo dito ng isa pang angle. Ayan. So, meron na siyang one axis of symmetry. So, for number 1, ang kailangan natin gawin dun kasi since itong mga given na to ay para sa single angle only. Ayan. Lagyan natin ito. Single angle. So, kung double angle na yan, ayan, ang mangyayari kasi yung overall y-axis natin ay andito na. Or ang centroid kasi niyan is andito na, di ba? Yan ay yung center of gravity natin. So, andito yung ating y-axis. Ayan yung x-axis, hindi naman magbabago eh. Andyan pa rin. Ayan. So, yung centroid, itong angle na to is andito. Ayan. Tapos ito, andito. So, with respect to x-axis, yung ating angle bar is hindi na natin kailangan mag-undergo ng transfer formula since yung mga centroids natin is lying sa mismong x-axis natin. Therefore, ang ating x-axis or yung moment of inertia with respect to x-axis is equivalent to 2 multiplied by 2.76 times 10 raised to 6. Okay? Ayan. By the way, wag muna to. Mas maganda kasi is introduce muna natin yung needed equation natin. Ayan. So, yung needed equation kasi natin, kung ang pinapahanap is allowable load, therefore, P sub A is equivalent to FA, ayan, allowable stress, multiplied by AG. And, yung ating allowable stress is magbe-base dito sa equation na to. Or depende kung long column ba or short column yung ating member or yung tinatawag natin na slender or non-slender column. Ayan. Depende siya. So, kailangan natin i-check. Okay? Yung slenderness, yung slenderness ratio. So, that is KL over R. And this should be less than or equivalent to C sub C. Ayan yung ating C sub C is equivalent to square root of 2 pi squared multiplied by 2,000. Sorry, this is E. Okay, yan. 200 gigapascal. Okay, tama. E over Fy. So, solve na natin itong C sub c natin. So, square root of 2 pi squared multiplied by E, which is, kung still to, di ba? That is 200 gigapascal. So, kailangan natin maging, megapascal, no? So, 200 times 10 raised to 3. Then, over Fy, which is also in megapascal. Ayan. So, 126.17. Then, kailangan natin ma-solve yung KL over R. Meron tayong L. Ang length natin is 4.5 meters. Tama ba? So, kailangan natin ma-solve naman yung R or yung radius of gyration. Kailangan natin mamili. It's either Rx or Ry. Kaso, itong Rx and Ry na to is, sabi ko kanina, is under sa single angle lamang. So, kailangan natin ma-solve muna yung Ix ito. Yan, yung Ix and Iy natin. Remember, yung ating R is equivalent to square root of Ix or I total over area cross. So, solve natin to. So, 5.52 times 10 raised to 6 millimeter to the fourth. Then, yung ating, Iy dito. With respect to y, since yung ating centroids ay wala sa mismong y, kailangan nating gumamit ng transfer formula. Okay? Para ita-transfer natin siya papunta rito. And remember, ang ating transfer formula is equivalent to I bar plus area d squared. So, yung I bar natin is yung Iy. Ito, 2.76. So, 2.76 times 10 raised to 6, then plus area, 2974 multiplied by d squared. Ito yung ating d. And yung ating d is equivalent to x bar. Ang x bar natin ay 31.24 times raised to 2. Then multiply natin sa dalawa kasi dalawa yung ating angle bar. So, ma-solve natin yung ating Iy. So, 2.76 times 10 raised to 6 plus 2974 times 31.24 squared times 2. So, 11.32 times 10 raised to 6 millimeter to the fourth. So, ma-solve naman natin ngayon yung Rx and Ry. So, square root of A over 2974, then times 2 natin. Kasi dalawa yung angle bar. Then, ang A natin, unahin natin yung Ix, 5.52 times 10 raised to 6, 30.46 millimeters. Then, 11.32 times 10 raised to 6, 43.63. So, ang tanong, anong pipili natin sa dalawa? Ang gusto kasi natin dito is at least mapaabot natin siya into failure mode di ba? So, ibig sabihin, kailangan mas malaki yung makukuha natin na KL over R. Okay, so, piliin natin is yung mas maliit na R. Okay, so therefore, R is equivalent to 30.46. So, ito yung tinatawag natin, ibig sabihin yung ating x-axis is yung weak. Okay, yung weak axis natin. Yan. So, yung ating KL over R is, wala namang sinabi kung ano yung K natin dito, pero i-assume natin na pin and pin yung ating support. Okay? So, kung pin, 1.0 ang ating K. Then, L is 4.5, then times 10 raised to 3 over R na 30.46. So, 147.73. Yan. And this is greater than cc na equivalent sa 126.17. So, since greater than tayo, therefore, long column ang ating member. Ngayon, kung long column ang ating FA or allowable stress is equivalent to 12 pi squared E over 23 multiplied by slenderness ratio. So, actually, hindi na ako masyadong familiar dito sa equation na to kasi under pa yan sa sa old version ng NCP. Sa NCP 2015 kasi ako halos nakabase ngayon sa mga tinuturo ko. And ito yung lecture namin sa compression member under sa torsional buckling and flexural torsional buckling. So, ito yung mga equation under sa NCP 2015 requirements. Ang pinagkaiba lang naman nila is, actually ito, mas gusto ko yung 2015 kasi ang sinusolve muna is yung nominal load. Okay, which is equivalent to FCR multiplied by AG. So, overall, equation. Ang nagbabago lamang is FCR, depende kung ano yung ating cross-section. So, for double angle or T-shape, ito yung FCR. Then, ito naman for all other cases. So, double symmetric, single symmetric, pero pag unsymmetric member, ito naman yung ating FCR, magiging FE na siya. Then, pag nakuha natin yung FCR, makukuha natin yung nominal. So, from nominal, makukuha natin yung design strength kung LRFD, then allowable strength kung ASD. So, dito lang sila nakakatalo sa dalawang to. Okay, so mas, parang trip ko, ang NCP 2015. Yan. So, ito yung ginamit namin dun sa aming playlist. Anyway, so, tuloy natin yung pag-solve. So, makukuha natin yung ating FA. So, 12 pi squared multiplied by E na 200 gigapascal over 23 multiplied by KL over R, which is yung 147.73 natin. Pero, hindi dapat tayo lumagpas sa So, ang ating KL over R ay 147.73 squared. So, 47.19 mega pascal. And then, makukuha na natin yung allowable strength or allowable load natin. So, this is 47.19 multiplied by AG. So, dalawa to, 2974, then times 2. Then, divide natin na 1,000 para maging kilonewton. So, 280.69. Ayan. So, ang sagot naman natin is 281 kilonewton. So, siya na rin yan kapag ni-round off natin. Okay? So, for number 2, find the allowable load for single angle. So, kung single angle lamang yan, okay, ito lang, under yan sa with no symmetry. So, kung tingnan natin yung lecture natin sa NCP 2015, under yan dito. For unsymmetric members. So, gamit tayo ng FE, then yun yung substitute natin as FCR sa ating PN. Then, ang equation ng FE is ito. Ayan, kukuha natin yung FE dito. Though, meron naman tayo mga equation ng FEX, then FEY, saka yung FEZ. Kaso, kailangan given itong mga to. Yung KZ, yung J, yung CW, or yung warping constant. Okay, then, kailangan given yung X sub O and Y sub O para makuha rin natin yung R sub O bar. And so, napakaraming kailangan hanapin rito. Pero dapat given din. And based talaga dito sa ating problem, wala naman yung mga given na yun. So, under pa rin talaga ito sa old version of NSCP. Okay? So, ganun pa rin naman. Check pa rin natin yung ating slenderness ratio. Pero, yung ating angle is mag-bend sa Z-axis. Therefore, yung ating KL over R is KL over R Z. Okay? So, ang ating RZ is 19.75. So, 1.0 multiplied by 4.5 times 10 raised to 3 over 19.75. So this is 227.87, 227.85. And ang ating KL over R is greater than pa rin sa ating C sub C. Therefore, long column ang ating member. Kaya, yung ating FA pa rin is equivalent to 12 pi squared E over 23 multiplied by KL over R squared. So, ang ating FA is, palitan na lang natin yung KL over R dito. Ayan. Ang ating KL over R na niya is 227.85. So, 19.84 megapascal. So, ngayon, ang ating PA is equivalent to, asan yan? Ito. Ayan. So, this is 19.84. Tapos, ito kasi naka-times 2, di ba? Kasi double angle yon. Single angle tayo sa number 2. So, tanggalin natin yung times 2. So, ang sagot is 59.04. Or 004. So, 59.00 kilonewton. Ang sagot is 59.03. Then, last, for number 3, find the length of a single angle if based on the limit of slenderness ratio for a compression member. So, ang limit kasi ng ating slenderness ratio is less than or equivalent to 200. So, kung dito mabibase yung ating length, therefore, ang ating KL over R is equivalent to 200. Yan. Tapos, ang pipiliin natin na R is yung pinakamaliit, 19.75 millimeters. So, makukuha natin yung L. So, L is equivalent to 19.75 multiplied by 200. Divided by 1.0 na K. So, wala na rin naman yun, hindi ba? So, millimeters ang makukuha natin, pero meters ang pinapahanap. So, 19.75 times 200. So, 3,950. Then, divided by 1,000 para maging meters. So, 3.95. Actually, pwede rin natin namang isolve yung ibang length based on different ranges of gyration. Kaso ang makukuha kasi natin na 17, ito kasi based on RZ, no? So 17 LZ to. So 17 po natin yung LX and LY. So 200 multiplied by ang natin RX, ilan nga ba pala? RX is 30.84. Then, divided by 1,000. So, 6.17 meters. Tapos, RY is 30.48. Teka lang. 40, paras na pala. Okay? So, paras na pala sila. Ayan. 48 pala, hindi 84. 48. Ayan. So, 6.10. So, ang ating LX and LY is equivalent to 6.10 meters. So, anong pipili natin sa dalawa? Yung 3.95 or yung 6.10? Siyempre, yung 3.95. Kasi, as long as sumahaba yung ating column, okay, or yung compression member, mas masasubject siya sa buckling. Hindi ba? Masasubject siya sa failure mode na buckling. Kaya, siyempre, pipili natin is yung pinaka-maliit. Kaya, yung ating L is equivalent to 3.95 meters. Okay, ayan. So, yun nga, ulitin lang namin kung since kasi ngayon parang ang ginagamit natin is NCP 2015. Kaya kung gusto niyo matuto on how to solve compression member under sa flexural buckling, torsional buckling, and flexural torsional buckling, you can visit our playlist on steel design. Ayan, under chapter 4, ito yung flexural buckling. Then, ito yung second topic na under sa flexural torsional buckling. Ayan. So, visit nyo lang siya. Okay? So, ayun na. Ito yung ating situation number 13 from CE Board Exam, November 2019. And if you enjoyed and learned from this video tutorial, you can subscribe and hit the bell icon for notifications and updates on our YouTube channel. So, thank you for watching. Bye-bye!